everyone. In this video, I'll talk about evaluating and tracking LLM experiments with an open source library called TruLens. I'm Anupam Datta. I'm co-founder, president, and chief scientist at Truera, and a former professor at Carnegie Mellon University. As you have all observed, there's tremendous developer activity in building LLM applications, ranging from question answering to chatbots to search and many more. And one paradigm that has started dominating is building by chaining. I'm sure you have seen frameworks like LangChain and Llama Index, where in addition to LLMs, other resources such as vector databases and agent-oriented plugins are being combined to build effective applications. Along with this trend comes an observation that there are significant challenges with ensuring that LLM applications are reliable and are of a high quality, that they are honest, harmless, helpful, and can be operated while managing cost and latency effectively. To make things concrete, we will focus on the use case of question answering chatbots that are built leveraging retrieval augmented generation, meaning not only do we have an LLM here, but also a resource such as a vector database, which includes a source of truth or knowledge base. A good example of this was Morgan Stanley storing in their vector database 100,000 documents, which came from their financial reports, financial analysis, and then the answers are generated not just from the LLM itself, but by leveraging the source of truth. As LLM applications are being built, it's very important to do experimentation. The typical workflow is for the developer to build an initial version, manually test and eyeball results, and if those don't look very good, to iterate with prompts, hyperparameters, and fine-tuning. Unfortunately, this process is not well supported by tools. There is in particular a significant gap in tooling to evaluate and track LLM experiments, and that's precisely the problem that we address with TruLens for LLMs. You can find it on this GitHub repository and play with it yourself. I want to show you the quick workflow of how to use TruLens. It's very easy to get off the ground. In step one, you are building your LLM applications in your framework of choice, native Python, LangChain, Llama Index, or something else. And then with just a couple of lines of code, you can connect TruLens to your LLM applications and start logging records, prompts, responses, intermediate results. And in addition, you can add feedback functions to log and evaluate the quality of your LLM applications. So this is a new piece of technology abstraction that we have introduced in TruLens that allows you to evaluate LLM applications systematically, and it's extensible, so you can add your own feedback functions based on your use cases. Once you have this machinery in place, you can see the results and explore records, evaluation results, and LLM chain versions in a TruLens dashboard. And that can both help understand the failure modes of your LLM applications, as well as get insights that can inform improvement and iteration on these applications and help you with selecting the best version for your task. Just to give you a feel for TruLens in action, here on the left of the screen is it's the core of a LangChain app setup for a question answering application, and you can see that the details here are not so important, but you can see that Pinecone is used as a vector database. This is using some version of OpenAI models as the LLM of choice. And then they are all stitched together in this chain at the bottom that composes the LLM with the vector database to build a question answering system. And then on the right is just the one line of code with which you can instrument your LangChain app to record the prompts, responses, and intermediate results, as well as invoke these feedback functions to evaluate how the application is doing with respect to language match, relevance, and context level or QS relevance. Feedback functions are an important technology abstraction that lets you automatically get a score after reviewing an LLM app's inputs, outputs, intermediate results, and metadata. And it can be used to build you can use lots of different feedback functions. The language match is a particular example. It's very easy to implement. In this case, just calling out to a Hugging Face API, which in the back end uses a Roberta model to check that the prompts and responses are in the same language. There's lots of other additional examples: prompt sentiment, language mismatch, transcript length, fairness substitution, context relevance, and so on, that come out of the box with TruLens, but you can also add your own feedback functions, and indeed that's what we are seeing many users of TruLens do. Let me now walk you through a very quick demo of TruLens. In this demo, we will see how this question answering app is evaluated, and the experiments are tracked with TruLens. The setup was that the Truera website and technical documentation was used as the source of truth that was broken down into chunks and indexed into a vector database. And then we have a few different feedback functions here that you can see. So up here is the first version of the app. You can see the average latency, total cost, and then these feedback functions: relevance, context level or QS relevance, and language mismatch. Let's drill down one level deeper to get a better view into what's going on here. And let me focus on one particular record here. And in this setup, the question that was asked of this question answering system is, where is Schreck, which means who is Schreck in German. Down here is the response. And then you can see how the application did on the three feedback functions we have set up. You can see that on overall relevance, it did quite well. It was somewhere in the middle on context level relevance, and on language match, it did particularly poorly. And you can tell why. The question was asked in German, the response was in English. And in fact, this is a very common failure mode for LLM applications. And the fix in this particular case is to make the prompts more specific and instruct the LLM to produce a response in the same language in which the question was asked. And indeed, in a later version of the app, when we make that change, the LLM application does well. Questions in German start getting answered in German as well. This QS relevance or context level relevance example is even more interesting. So recall that when the question is translated into embeddings and then matched against available potential answers in the vector database, a few different sources or context chunks are retrieved from the database. In this particular instance, these 4 chunks were retrieved. And you can see on each individual chunk, we are asking how relevant is this chunk to the question that was asked. And the implementation here is done using another LLM. And in particular, you'll see the top 2 chunks are about Shrek. And then the implementation of the feedback function correctly identifies those as being about Shrek. But the bottom 2 chunks are about a different person at Truera called Shamik. And so these 2 chunks are actually not relevant to the question of who is Shayak, and our feedback function implementation correctly identifies them as not relevant. So you see the low score here of 0.1 and these rows being marked in red. Now, this also suggests a potential fix. The potential fix in this case is to filter out the context chunks that are not particularly relevant to the query. So in this example, the bottom 2, because the feedback function scores are below a certain threshold, let's say below 0.8, and then only the top 2 chunks, in this case, the relevant ones, are sent to the completion prompt, the completion stage, for the LLM to produce the final summarized response. And indeed, that's what we see work well in the final version of the app. So if I go back to the leaderboard, you will see this iterative process of improving the app. We started with the baseline app, which did not do very well on QS relevance or language match. Once we updated the language prompt to be specific and make sure that the response was in the same language in which the question was asked, the language match score goes up. It's doing well there. When we do the context filtering, meaning only the relevant context gets sent to the summarization stage, you can see the QS relevance score goes up to 0.9 from the original 0.52. So that's another step forward. And finally, in this final version of the app, we do both. And when we do both, the QS relevance goes up to 0.9, language match goes up to 0.93, indicating that this app is now ready to be moved into production. And if I go down here and look at this particular record in a bit more detail, you'll see that all the feedback function scores are now much higher. The older issues have gotten addressed. Only the relevant chunks about Shayak are being used to produce the final summarized response, and that when the question is asked in German, the answer is also in German. So this is a good overview of this example of how to use TruLens to evaluate and track LLM experiments. There are a number of other use cases that we have not gotten into. Sometimes, in fact, hallucinations can be correct. In this case, we're asking, name some famous dental floss brands. Although the answer is correct, the context chunks actually don't produce the answer. So this is a case where groundedness doesn't hold. Or sometimes we might be answering the wrong question. So here we are asking, which year was Hawaii State song written? The answer is not about the year, but the name of the song. So you see QA relevance breakdown. And these are just some representative examples of the kinds of issues with LLM apps that can be identified with TruLens. We encourage you to try it out yourself. Go to our GitHub page and engage with us. Give us a star, request a feature, contribute. We are looking forward to growing the community around evaluating and tracking LLM experiments. Thank you very much.